unit, which is going to be on solving quadratic equations. And in preparation for learning how to do that, we also need to be comfortable with simplifying radicals. So that's what we are going to be going over today. So before we do that, on the do now, I want to just talk about what is the difference between a rational number versus an irrational number. So for part A, which expression is rational? So the choices are pi, 0.76, the square root of 14, and the square root of 12. Now, pi is the most famous irrational number. Pi day is March 14th, 3.14. So this is irrational because it is a non-repeating decimal that never ends. It's 3.14159, but it goes on forever. Now, if you look at choice 2, 0.76. Now, this is a decimal, but it stops. That's called a terminating decimal. So that is okay. That is rational because it stops. Okay? Now, if you were to type in square root of 14 in your calculator, which I'm doing right now, you get 3.74165. Okay, so long, yucky decimal. Out. Okay, so no. Now, if we type in the square root of 12, we get 3.464101. Again, yucky decimal, so this is out. Okay, so the definition of a rational number. So the technical definition is a number that can be written in the form of a fraction. I don't know why I'm writing this because you have the notes. In the form of a fraction. But the way I want you to remember this is that a rational number is a number that's a decimal that ends, that stops, or just a nice regular number. It could be 3, it could be -2. All of those are rational numbers, okay? So I'm just going to erase this a little bit just to go to number 2. All right, so now in the second one, which number is irrational? So now we're looking for the number that does go on forever without a pattern. So 5/4, if you actually divide that in your calculator, you get 1.25. That's fine. That is good. That is a rational number. And it's written in the form of a fraction, which by definition means it's rational. Now 0.3 with the little line on top, that line means that it's going on forever. So this is just 0.3 repeating forever. That is rational. There is a pattern. Okay, so this one is a rational number. The square root of 121. If you type that into your calculator, you get 11. Nice whole number. We're good to go. There you go. Dingy, dingy, dingy. Pi, our most famous irrational number. It is a decimal that goes on forever with no pattern. So our definition of an irrational number is a number that cannot be written in the form of a fraction, but you can remember it as a yucky decimal. It's the technical term, yucky. I'm kidding. Okay, all right, very good. So now we're going to talk about our perfect squares. Now, in our last unit, when we did factoring difference of two squares, you saw this a little bit there, and we're going to go over it again now. Okay, so let's just go through the first 10 for right now. So the way we generate this list is we start with 1 squared. So 1 squared means that we are doing 1 times 1, which is 1. Okay, now 2 squared means we're doing 2 times 2, which is 4. Okay, we're just going to keep going. 3 squared, which means we're doing 3 times 3, is 9. 4 squared, which is 4 times 4, is 16. 5 squared, so 5 times 5, is 25. 6 squared, which is 6 times 6, is 36. 7 squared, which is 7 times 7, is 49. 8 squared, So 8 times 8, 64. 9 squared, 9 times 9, 81. And 10 squared, we'll stop here, 10 times 10 is 100. So this bottom list that we just generated just by counting up and squaring our numbers, these are our first 10 perfect squares. Now, what that means when I say that a number is a perfect square. So let's take a look at 36, for example. The reason that 36 is considered a perfect square is because I can write 36 as 6 times 6. So the fact that I can rewrite 36 as the product of two numbers that are the same means that it is a perfect square. Okay? That's what that means. So we are going to be today talking about our perfect squares and then you'll see in a minute, simplifying radicals. Okay, so I'm going to skip over this for right now. I'd like to just get into the good stuff. So let's talk about radicals. So the quantity or expression under the radical sign is called the radicand. 1 second. This is the radicand. Okay. My terrible little math joke, the square root of a chicken is the egg. So funny, I know. Okay, so I'm going to go through these examples. I'm going to first do 1 and 2, and I'm going to just talk you through the steps, and then we'll discuss the steps a little bit more in depth. So if I want to simplify the square root of 12, now, if you type in the square root of 12 in your calculator, you get 3.464101615, blah, 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 blah. So the square root of 12, this is an irrational number. Now, when I'm asking you to simplify the radical, I don't want the long, yucky decimal. Anybody can type that in their calculator and get that. What I want is this in simplest form, and I'll show you what that means. So the first thing we're going to do is get our factors of 12. Now, you might remember from the previous unit that when you want to get your factors of a number, go into your calculator, and you can go into the y equals, and you'll type in this case, 12 divided by x. Then you'll go into your table and you'll start at 1 and you're going to get 1 and 12, then 2 and 6, 3 and 4. Now the next one you're going to see is 4 and 3, but you don't need to include that because it's just a repeat of 3 and 4. So you can stop there, you're done. Okay? So now I'm going to look at this list and I'm going to ask myself, all right, where in this list do I see any perfect squares? So when I'm looking at this list right now, I see the 1 is a perfect square and 4 is a perfect square. Okay? Now the 1 is always going to appear in the list. So the second thing I ask myself now is, okay, of those ones that I just determined are perfect squares, which one is the biggest? So 4 is our largest perfect square. And we know that 4 has to multiply by 3 in order to get up to 12. Okay? So here's what we do with that information. So I'm going to go down here, and I'm going to take my perfect square. So we're using this pair of numbers, the 4 and the 3. So I'm taking my perfect square, and I'm listing it under here. So we're doing radical 4, and then I'm going to put the radical 3 over there. I always put whoever is the perfect square first. Okay, that always is who gets listed first. Now the square root of 4 is 2 because 2 times 2 is equal to 4. Okay, now in your calculator, to get the square root button, you hit second x squared. Okay, so second x squared, and then you'll just type in 4. Now the square root of 3, this is an irrational number. It's going to come out to be some gross decimal, which I don't want. So what I'm going to do is I just bring down my radical 3. And there's my answer. So radical 12 and 2 radical 3 are the exact same number. If you were to type in 2 radical 3 in the calculator, you would get the exact same decimal that you got when you typed in radical 12. It's just that this is now considered simplest radical form. Okay? All right. So let's go through number 2. We're going to follow the exact same steps. Okay. All right. So for number 2, we are simplifying the square root of 27. So we are going to list our factors of 27. Again, you can go into your y equals on your calculator and type in 27 divided by x and go into your table. And we get 1 and 27 and 3 and 9. Okay? After that, 4, 5, 6, 7, and 8 are all decimals, and then you would just get 9 and 3, which is a repeat. So now you want to ask yourself, okay, where do I see perfect squares in this list? Well, 1 is a perfect square, so that's always going to be there. The only other perfect square I see is 9. Okay? So what that means is that I am using 3 and 9 over here to simplify my 27. Now, we always list the perfect square first. So this is radical 9, and then over here is radical 3. Okay? Now, to simplify the square root of 9, you can put it in your calculator if you don't know it, but the square root of 9 is 3, because 3 times 3 equals 9. And then radical 3 is just some yucky number I don't want to deal with, so I'm going to bring down my radical 3, and bada bing, bada boom, we have our answer. So again, radical 27, I just want to make sure that we understand this. Radical 27 and 3 radical 3 are the exact same number. It's just that the 3 radical 3 is in simplest radical form. They're the same thing, they're just wearing different outfits. That's all. And the guy down here is wearing the simplest radical form outfit. Okay? All right. Let's take a look at number 3. So here we've got 500. So for 500, there are going to be a lot of factors. This is why it does help to use that trick with the y equals and then doing the number divided by x. So our factors end up being 1 and 500, 2 and 250, 4 and 125, 5 and 100, 10 and 50, and 20 and 25. Okay? All right, so now I have a lot more options than I had in my previous examples. So let's look through this list, and we're going to find where do we see perfect squares in this list other than 1. So let's see, I'm going through my list. Okay, well, boom, we've got 4. That's a perfect square. We've got 100. That's another one. And we've got 25. So we actually have 3 choices here for perfect squares, but you have to make sure we're looking for the largest perfect square. So my largest perfect square is 100. So that means that we are using 5 and 100. So my perfect square goes first. So the square root of 100. And then over here we put the square root of 5. Okay. Now the square root of 100 is 10. And radical 5 is just going to be some yucky decimal. So we just bring down radical 5. And there you go. Simplest radical form. Okay? So those are your steps. And we're going to talk about the steps now down here and just write them out so you have them down for you. Again, the copy of this notes is in Google Classroom, so you have all of this here, for you to refer to later. So steps for simplifying radicals. So you want to find the factors of the, let me make this a little bit bigger, of the radicand that has the largest perfect square. Okay, that's your first step. So that was the part where we listed the table and we picked the highest perfect square. So for step 2, write both factors, put the highest perfect square first. So if you look back at the example, so like here, we put the square root of 100 came first. Here we put the 9 first, the 4. So the perfect square always was listed first. Now step 3 is we simplify the perfect radical So it comes out of there. So like here, when we did the square root of 100, it became 10, but it's outside of the radical now. And keep your non-perfect radical. So here we just brought down the radical 5. Okay? All right, and now we are going to do some practice. Okay? All right, so guys, this is the exact same procedure every time. We are always going to list our factors, find the largest perfect square, simplify. It's the same every single time. All right, so 54. All right, so my factors of 54 are, just make this a little bit bigger, 1 and 54, 2 and 27, 3 and 18, and 6 and 9. Okay, so I'm looking at my list and I'm looking for perfect squares, and we've got one right here. We've got 9. Okay, so that means that the pair of numbers that we are using, 9 and 6. Okay, all right, so let's go back over to our problem. So that means that the 9 is getting listed first, and then the 6 is getting listed second. Now, this problem has something else in it that's different from before. It has this number in front of the radical that we're simplifying. You just bring that number down. Okay, it doesn't change the steps of the problem. It's just another number that you're going to bring down. It stays outside of a radical, so don't get too excited about that, okay? All right, now the square root of 9 is 3, and then radical 6, so that's an UCI decimal, so we bring down the radical 6. And now the final thing we have to do in this example, because we have this number that was originally in front, we're going to bring that down also and multiply. So we're just going to multiply these two numbers together. So 5 times 3 gives us 15 radical 6. Okay? All right. On to the next. Okay, number 5. All right, so 4 radical 24. Okay, so get our factors of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay? All right, so I'm checking out my list, and ding, 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 there's my perfect square. So that means that the pair I'm using is 4 and 6. So let's go back over here. So I'm going to put my 4 first right here and my 6 second. And then I'm going to bring down that 4 that they had in the beginning. Okay. Now the square root of 4 is 2. And then we just bring down the radical 6. And now don't forget to bring down the guy that we started with, the 4. And we just multiply these two together. 4 times 2 gives us 8 radical 6. Okay? Now again, the 8 radical 6 and the 4 radical 24, you should, if you want to check, type this into your calculator and type this into your calculator. They should be the exact same number. You should get the same exact decimal. Remember, I said the value is not changing, just the outfit. It's just going to look a little different. Just one other thing to mention before we continue. It would, I think, be helpful for you at the top of your paper to jot down your perfect squares, just so that you have that list in front of you. Now, you don't need to memorize these, okay? If you just, hold on. So if you just think in your head, okay, what is 1 squared? Well, 1 squared is 1. What is 2 squared? 2 squared is 4. 3 squared is 9. 4 squared, 16, and so on. That's how you can generate your list without having to memorize this whole thing, okay? But sometimes I think having this right in front of you just sort of helps when you're trying to determine where's my largest perfect square, okay? All right, so back to our problems. So 7 radical 72. So I'm going to list my factors of 72. So 1 and 72. 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. Okay, so let's go through our list, see where we have perfect squares. So we've got 36, 4, 9. So we have a few, but remember, we only want the biggest one being, in this case, the 36. Okay, so we are going to break this into, now the 36, remember, comes first. The perfect square comes first. So the square root of 36 and the square root of 2. And then we bring down our number from the beginning. You're not always going to have a number in front, a coefficient, but if you do, that's how you deal with it. All right, now the square root of 36 is 6. We bring down the radical 2. And then we bring down the 7 that we started with. And then just multiply these together. And we get 42 radical 2 as our final answer. Okay? All right, very good. Let's keep going. Number 7. So 4 radical 96. Okay, so let's make our list. So 96. So we've got 1 and 96, 2 and 48, 3 and 32, 4 and 24, 6 and 16, and then 8 and 12. Okay, so let's look at our list, see where we have perfect squares. 4 is a perfect square, and 16 is a perfect square. Okay, but remember, we have to ask ourselves, who is the biggest? And that is, in this case, 16. So we're using this pair of numbers, the 6 and the 16. So when we break this down, we list the 16 first, so the square root of 16 and the square root of 6. Okay, now the square root of 16 is 4. And we just bring down the radical 6. And now since we go back to the beginning, we had that 4 in the front to start. So remember to bring that guy down, include him in the answer. So when we multiply the 4 times 4, we get 16 radical 6. Okay? Very, very good. All right. Number 8. 8 radical 48. Okay. So let's list our factors of 48. So 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Okay, so in our list, our perfect squares are 16 and 4. And our largest perfect square then is 16. So that means that that's our pair that we're using, the 16 and the 3. So we're going to branch this to our perfect square pile, 16, and our non-perfect square pile, the 3. So the square root of 16 is 4. And we bring down our radical 3. And now don't forget the guy we started with, the 8. So we're going to bring our 8 down. And then 8 times 4, we get 32 radical 3. Boom. Isn't this fun? No? You don't think so? I like it. All right, so number 9, 2 radical 75. Okay, so my factors of 75 are 1 and 75, 3 and 25, 5 and 15. So looking at this list, we've only got this guy right here, in addition to the 1, obviously. So we don't even need to look for the largest because he's right there. So we're using 3 and 25. So this gets broken down to radical 25 and radical 3. So the square root of 25 is 5. And then we bring down our radical 3. Okay. And remember we had the 2 in the beginning, so we bring that down. And 2 times 5, we get 10 radical 3. Okay, very good. Alrighty. The rest of these are just really the same thing. And again, I have the answer key up for you on Google Classroom. So if you want to come to one of my Zoom sessions, I can continue to go through these. If there's anything, if you look at the answer key and you don't understand something that I wrote out, come to a Zoom session, email me, send me a remind. We can do a private Zoom session, whatever. We will figure it out, okay? So next week we'll be talking about quadratics. So I hope you enjoyed this day into simplifying radicals, and I will speak to you guys later. Okay, bye.